Hi guys, how are you? So today I welcome you in a feature engineering series tutorial number 3. In this tutorial I'm going to show you how you can handle rare occurring labels in your dataset. Alright, so this video is going to be almost the 60-minute long video. The first I'll start about with the introduction of rare labels. Thereafter I'll be talking about what could be the effect of rare labels on your machine learning algorithm. Thereafter I'll be describing you about the dataset which we are going to use in this video. Thereafter I'll be showing you some analysis on the rare labels and how these rare labels are occurring in your dataset, and then we will be doing some visual analysis of rare labels. And once we are done with the visual analysis of rare labels, I'll be showing you how you can group your rare labels together so that you can reduce the probability of overfitting and underfitting. And then finally I'll be showing you a visualization to understand that how a rare label could be important in your dataset if they are taken collectively together. So this is going to be really very important and interesting lesson. While following this 1 hour long video lesson, you might feel lazy. But one thing I'm 100% sure that this video is going to be really very helpful in your data science journey. So please do not forget to watch this video, and please do like this video and subscribe this channel. Now let's go ahead without wasting time, get started with this lesson. Alright, so without wasting a time, let's go ahead and get started with how to handle rare occurring labels. So what are these rare occurring labels? You might have heard about the imbalanced data set. Alright, so the imbalanced data set is an also example of rare occurring label. So in rare occurring labels, what happens? There are a few labels in a target variable, or you can say in the input variables, which occurs very less number of times. So the difference is here, if rare label occurs in the target variable, that is actually imbalanced data set. That's mean for some type of a label, number of rows are high, and for some type of labels, number of rows are less. But the same problem also happens in a feature input. All right, and that means in the input data. So if in input data, in a categorical data, if some type of the categories are occurring less number of times, that is the example of rare labels. Alright, so you can understand it in this way. Like let's say in a data set you are given and you need to get the information about the oil fields present in the world variable. Alright, that's when there is a data set and there is a variable in which you need to identify that oil field countries. That is the input. So in oil field input in a variable, you might get a lot of, more number of times Saudi Arabia, Kuwait, Iran, Iraq, etc. So these might appear frequently. Then other countries like US, Canada, India, Russia, because these countries are only a minor oil producer countries, and the major oil producing countries are Saudi Arabia, Kuwait, Iran, Iraq, etc. So what will happen here? You will be having more number of mentions of these countries in your input dataset and less number of mentions of these countries like US, Canada, India, Russia in an input dataset. So if we just take it in a binary variables kind of that, you will see there is one type of label which occurs most number of times, and there is another type of label which are occurring only few number of times. So these we are gonna say these are rare occurring labels, and these are actually majorly occurring labels. So our task is to handle how we can handle these rare occurring labels. Do remember, this is not for a target label, this is for input label. So in input we are talking about, there is a variable oil field country. All right, so there we have Saudi Arabia, Kuwait, Iran, Iraq. So these will be occurring most number of time, these are frequent occurring, but these will be occurring less number of times. And let's say in the target we want to predict the economy of the country. All right, so in that case we might see the most number of times these countries in the oil field column, and these countries less number of time in oil field. All right, so now the question is, are these rare labels in categorical variable is a problem? Yes, rare variables or rare labels could be a problem sometime and could not be a problem sometimes. So if it is a problem only for some time, then we should consider that it is a problematic condition in our machine learning algorithm. What are the effects which can happen because of this rare labels occurring? For example, let's go ahead and consider our previous example which we took just for a reference. Oil price may not be controlled by only some of major countries like Saudi Arabia, Kuwait, Iran, Iraq, but this could be also controlled by US, Canada, India, Russia. All right, now again, so the oil price also could not be controlled only US or Canada or India, Russia. I mean only a particular country, but it could be controlled by all these countries together. Although these are in minority in number of oil producing fields, but if these countries come together, then they might affect the oil price as well. So in the same manner, it can happen, rare labels can also produce a lot of effect in a final outcome if they are considered together, and they might not produce any effect in the target output if they are considered exclusively, that's mean alone. That's why it is very important to handle rare labels. So what are other effects of rare labels? Rare values in categorical variable tend to cause overfitting and the underfitting. The overfitting and underfitting, that's mean we can estimate the effect of these less occurring countries. We can overestimate its effect or we can underestimate these effects. So these could be a problem if there is rare occurring labels. A big number of infrequent label adds noise. Let's say if there are the hundreds of infrequent label out of these 200 countries almost, so these might add a noise, because for a few countries there will be only one or two entries, and individually those entries might not affect the target at all. And the rare labels may be present in the training set but not in the test set. That is also a problem. For example, let's say if a single label in the input variable is present only in the overall input, and if we divide it in the test and the train set, then that particular only one label may fall into a training set or a test set. So that's also gonna be a problem. If that only a particular label appears in the test set, then that could be a problem, because in the training set, machine learning algorithm had not seen any such type of the labels. And if only comes into the training set and not in the test set, then in that case it could be also a problem of overfitting or underfitting. So the overall, there is a huge effect of rare labels, and for a data scientist this is really very important to analyze the effect of rare labels in their machine learning algorithms. All right. And if we take here another example for rare labels could be important. And now let's take some other example. And now we are taking a space exploration mission example. In space exploration mission, rarely occurring events could be a very important. That's mean rare labels could be important for a final outcome. So in this video, we are going to cover how to identify rare labels in the dataset and understand how difficult it is to derive reliable information from rare labels, and we are also going to visualize the uneven distribution of rare labels between the training and test set. Alright, so let's go ahead and get started with the coding. So in the coding, first we will start only with these import and the dataset. So these I have already written in the notebook, and thereafter I'll be showing you a line by line code, and then I'll be showing you how you can analyze the effect of rarely labels occurring. Alright, let's go ahead and get started with this. So we'll be using few of these libraries which are already available in a Python, like pandas, numpy and matplotlib. And thereafter we will be using here a train test split. So pandas will be used to read the dataset into a data frame, and pandas will be also used to perform the operation along with numpy. Alright, matplotlib will be using for a data visualization, and train test split we will be using for splitting our dataset into a training and testing set. And the dataset is available at a Kaggle, and you can get it from here at the from this link at the Kaggle. And this is a link on the Kaggle house prices advanced regression technique. Alright, so this is the data set, and in this data set it has here data description. And this data set are having here, this data set is having the four files: train.csv, test.csv, data description.txt and sample submission.csv. Alright, and out of these files, we are just going to take train.csv file. So this is the training set. Because we don't have a target label for a test set, so we won't be able to make any assumption here. We won't be able to make the comparison. And this train test will be storing it like housing data. So there are many input fields like a sale price. So this one is a target variable. In general, in machine learning, supervised machine learning algorithm, which we predict, that is the sale price. And these are some other input variables, or you can say input feature space. Based on these input variables, in general, our machine learning algorithm predicts the sale price. And out of these input variables, we will be taking only 3 variables for our analysis. Those 3 variables are neighborhood, exterior first and exterior second. So what are these? Neighborhood means a physical location within the city limits, and that's mean what are other physical location within that city limits around that house. What are material used, first type of material, and what type of second material is used covering the house, and this one is the target label. Now to understand it in a more detail, you see there exterior first is exterior covering on house, and this is the second type of exterior if it is used. And there is neighborhood. So in the neighborhood we have a physical location within the AM city limits. So these are the input, the target input feature space variables. Although there are many more, but we are just gonna take these we are just gonna take these three for our analysis. So out of these three, I'll be showing you how these rare occurring labels are affecting a final house sale price. Alright, so let's go ahead and run this cell, so which we have already imported: pandas, numpy, matplotlib, and train test split. Thereafter, we are gonna create here a list for all these labels which we are gonna read from the dataset. Now you see this dataset is currently available on a Kaggle, and at the same dataset I have already stored on my GitHub profile Lakshmi Merit all CSV ML data files. So you can click on this Lakshmi Merit actually. So it's available at this link. Alright, GitHub Lakshmi Merit. Thereafter you have here all CSV ML data files, and in that all CSV ML data files you will be having here house price. Let me see, yeah, there. So this house price, if you click on this house price, it will open this CSV file, a rendered CSV file inside this GitHub profile. Alright, so it is taking a little time, yes. Thereafter you need to click on this raw. Once you click on raw, you will get this CSV link. Do you see there? House price.csv. Alright, so we need to copy this one, this CSV file. Now we are gonna read it directly from here. Now do you notice here this link is the same link which we have copied there. Alright, so this link is already present there. And thereafter huge columns, we are gonna just read these four columns: neighborhood, exterior first, second, and the sale price. Thereafter we are gonna visualize the data. We are just gonna see first few rows of the data. So there we are using here head. So head here shows first 4 rows, and similarly you can also use there a tail. Tail will show you last 5 rows. Alright, now these three inputs are, these three labels are a feature space label, and this one is the target variable. Alright, which we predict in general. So what's happening here? We are going to find the cardinality of these variables: neighbors, exterior first, and exterior second. So the cardinality means how many number of times these variables have occurred in this particular column, and how many times these variables have occurred in this particular column and in this particular column. Alright, so to predict these n uniques, that's mean the number of unique, how many times it has occurred. Alright, so what I'm going to do, I'm just going to copy this one and paste it here. So you see there, this is a full column, but here we are gonna just take the feature columns. Alright, so there I'm gonna say here this one feature columns. That's mean these are the input features, and out of these input features I'm gonna just read these columns one by one for call in features, in feature calls. Thereafter I'm gonna just simply print here how many, the unique number of occurrence. So if you see here inside this data, and if we store, if we take this neighborhood, alright, so this is now series, and there is value counts. So in the value counts we get something like this. Alright, and this value count says that how many times these variables are occurring in this neighborhood column. And if you see there, this has occurred only 2 times. So it has a very high chance that it might end up only in train set or test set. So these things we need to understand. These are input feature. Alright. Now for a number of uniques, what you can do, you can simply write there n uniques, all right, like this. So if you type there n uniques, just a second, let me see. Yeah, that's not this n unique. So it says that total number of columns, that's mean how many different type of columns are present in a neighborhood, that is the 25. And similarly you can check for other two as well. So the same thing I'm gonna do here. All right, so the same thing I'm gonna do here, and that I'm going to do here with print statement. All right, so there I have a print statement, and in the neighborhood I'm gonna use here this column, and thereafter I'm gonna use here this one. All right, like this. So thereafter I'm gonna use here string format. There I have a column. All right, superb. Let's go ahead and run this. So it says that in neighborhood we have a 25, in exterior 1 we have a 15 unique variables, and in exterior we have 16 unique variables. All right, perfect. So these are the unique variables or labels, and let's go ahead and see how many rows are inside in the data set. So the data set is having total 1460 rows. So the data is having total 1460 rows. There are of course 4 columns, and these are the number of unique variables present in each column. So this is the one point. All right, so this might seems a boring lecture, but stay tuned till the end. You will understand this is going to be really a very important lesson in your data science path. All right, now let's go ahead and do some analysis on null. If any null values are present in the data, no. Let's go ahead and take the info of the data. It says that sale price data type is integer 64, and other 3 is object. So more or less they are a string data set. All right, so what is the total number of houses? How many total houses are there? So you can say like total houses is equal to data dot shape 0. If you remember, there we have printed this data shape, that's the 0th location 1460. All right, so there you have total houses. There are 1460. That's the total houses. Now let's go ahead and see what percentage of houses are present in the neighborhood. Let me make it clear in another way, so it might seems a little confusing for you. I'm saying here I have a data neighborhood, and these are unique variables. So I'm trying to say here that what percentage of unique variables of a particular house is present in a nearby. All right, so that's I'm gonna say here the value counts. So now do you see these are the numbers in the neighborhood of a particular house? What are the cities are the physical location of nearby cities, these. All right, and if you want a percentage, so in the percentage you need to multiply this one, you need to divide it by that one. That's mean the total houses. So it says that around 15%, 15% location is names location, and it seems some college. All right, so these are some physical location, and there is Old Town, Edwards. So these are the sum. So this is the 15%. That means to say that in a neighborhood column, and these variables are unique categories are mentioned 15% of time, 10% of time. So if you remember earlier, I told you that a major columns, a major variables occurring in a particular column might have a huge effect, and less occurring variables collectively also might have a huge effect on a final, that means the target output. So this is how you can see this. It is affecting overall. All right. Let's go ahead and plot it and see what's happening there. So there is, let's say, I'm gonna store it inside temp series. Thereafter, this temp series, I'm gonna just plot it. All right. So I'm gonna say here temp dot plot. That's mean bar. So I'm gonna use here a bar plot. Now what do you see in this bar plot? You see in a bar plot that there is first one is around 15 and the 16%. Thereafter it is decreasing. That's when these label occurrence are pretty much less. The sum of these labels are even happening less than in 5% rows. That's when this label is occurring in around 15% of rows. This one is around 10% of rows. But at overall, if you see at the less than a 5% here, that's the 5%. All right. So there, so most of these columns, these labels are occurring in less than 5% rows. All right. Perfect. So this could be a problem. All right. This could be a problem. Now let's go ahead and plot it for all the columns. All right. Let me plot it in more better way. Let's say you have here a PLT dot axis horizontal lines, and there I'm gonna say here 0.05. Sorry, this one something like this, and there I'm gonna say here this color is red. Now if you see there, that's the 5%. All right. And in this, I'm gonna say here the PLT dot X label, and sorry, this, there we have X label. In the X label, we have here a neighborhood. And thereafter we have here PLT Y label, and in the Y label we have a percentage of house. All right. And you might see this the text, we can remove this text if we type there plt.show. So with this we see this plot, and it says that this one is a 5%. All right. And this 5%, and there is, these are the columns. All right. So what's happening here? These are rarely occurring labels, and we might not be interested in these rarely occurring labels unless these are grouped together. So to understand its effect, moreover, on the final target label, that's the house price, we also need to plot here a mean price of the house for these particular labels. Only thereafter we will be able to understand its effect on the final target output. All right. But before that, we need to plot it for all these three columns. So we have these three columns: neighborhood, exterior first and exterior second. So for that, I'm gonna simply write here a for loop. So for call in feature columns, thereafter I'm saying here this temp is equal to data call, thereafter value underscore counts. All right. If you remember, it's actually the overall the same thing is happening. So we can simply copy it from there and thereafter I want to plot everything, so I need to copy those things as well. Thereafter, do you see this neighborhood? I'm gonna just put it as a column. I think this one I also need to put this column, and other things are okay. So these are 3 plot which we see here. So this one is for neighborhood. There we have exterior material. So in this there are a few labels which are almost occurred none number of times. That's mean it could be only one occurrence. So these rare labels would be a problem. And there. So you see, if we set the bar of 5%, in that more than half of labels are occurring less number of times. And that is actually rare labels. And those rare labels could be a problem in our final output prediction or final outcomes. So this need to be addressed properly, and then I'll be showing you how you can handle these things. All right, perfect. Now let's go ahead and see how the sale price is related to these categories. All right, that's mean these labels. And for that I'm gonna just create here how is sale price related to these categories. All right, so what we need to do, I'm gonna calculate a mean price for each of these categories, and then I'll be plotting here to see and understand how the price is varying for a particular type of the label. All right, so in that way we might be able to see a proper correlation between a final variable, that's the target variable, and input feature variable. So for that I'm gonna simply write here a method definition get underscore mean. There we have a sales price per categories. All right, there we have a data frame and category. So we already know the total houses, that is 1460. Thereafter we are gonna say we are gonna see here we are gonna first calculate this part. All right, that's mean this bar plot thing, and that bar plot thing are coming from here. All right, that's the temp. All right, thereafter do you remember one more thing, let me show you there. If we see a previously stored temp is like this, and in this temp if we do here a reset index, all right, so there we do a reset index. So earlier it was a pandas series, now it has become now pandas data frame, and in this pandas data frame then we can set the column, this one as a category, that's the categorical label, and this one is the percentage of house. That mean to say that this one is for exterior second, the exterior second material, these are the materials, and these are the percentage of house which are using this as a exterior material. That's mean 34% of houses are using this vinyl SD material, and 14% of houses are using this metal, then another 14% are using this one, and this one perhaps wood. All right, so these are the mostly and the majorly used material. There is a polywood is around also 10%. All right, even if we consider these 6, thereafter even less than 1% others. All right, perfect. So something like that I'm gonna do here. So and again temp is equal to temp dot reset index. All right, something like this. Thereafter, I have here temp dot columns is equal to cat, and that's the category for which category I'm gonna calculate. So like it could be the exterior second category and percentage of houses are there. All right. So that's going to be a percentage of houses. That's the temp. Now we have set there the temp. Now we are also going to add the mean label for a particular label in this column. All right. So how would you do that? Let's say you have a data and you want to calculate for exterior second. So it becomes something like this one. All right. And thereafter, we also need a sales price for this one. All right. So we are going to say like this, where this one, let's say for this variable, where this variable is like this one. So we'll be getting like this, true, false, true, false. Thereafter, if you see your data like this, so you will get there all exterior 2. All right, that means second exterior will be like this. Now we need to see that what is the mean price for this type of. There you need to type there just the mean, and it says that this is the price for this one. So the same thing we are going to do here. We are going to calculate for label by label to see what is the mean price in that particular category. All right. So it's like this. Mean price is equal to data frame dot group by. All right. So I'm gonna do a group by, a category by category. So for this particular, if I run a group by, you can understand it like this. Let me show you first head. If I run a group by for a particular column, it will group all the values, unique values together. All right. So df dot group by in that category. So these are the category. Since this is going to be a for loop, so we will be iterating one by one. So df dot group by, there is category, and thereafter I want a final sale price mean. All right. So it's like this, sale price mean, thereafter reset underscore index. So the overall, if you want to see this one, how it is gonna work, you can understand like this. And let's say this exterior, I'm gonna just put it here. All right. So it's gonna group by second exterior, and then it is going to calculate the mean for each unique variables. And if you run it, this df should be a data, you will get something like this. Now you see these are unique labels, and for each of these unique labels, we are having a mean sale price. And if you remember, for exterior second type of vinyl ST, this one is a mean value. And if you match it somewhere here, we should get that. Do you see there? It's exactly the same value. All right. So what's happening here? Earlier we had seen these percentage of house for each of these unique labels. Now we are also going to plot here what is going to be a mean house price for each of these labels. So that's what we are doing here. It might seem a little complex for you, but stay tuned with me. You are going to learn a lot of things in this lesson. All right, let's go ahead do a merging of a data frame. So the temp is equal to temp dot merge. So there I'm going to do here a merge, and in that I'm going to put this mean price, and this mean price I'm going to merge it on category. Do you see there this temp? We already have temp something like this. So and this is already, now we have assigned new column, that's the category, and there is this category. All right, so we are gonna merge these two categories together. So there would be exterior second percentage, a new column, and a sale price, another new column. So we are gonna do here a merge on category, on is equal to category, and how is equal to going to be a left. That's mean there would be a left merge. Once it is done, then we are gonna return a temp. So we need to make sure that you are understanding it clearly. So what I'm going to do, I'm going to just copy it here, and if you see their temp we already have. So I'm gonna say here temp is equal to reset index and temp dot columns there, and do you see there it's for exterior second. So I'm gonna, sorry, this should be like this one, no issue. This I'm gonna set here the exterior second, and thereafter I'm gonna just see a temp. So this one is my temp, and now do you see there this one is data group by, and this variable I'm storing in mean price. So I'm gonna simply put here a mean price, and now do you see there mean price, we are getting this one, and temp is this one. Now the thing which I want to show you, this the merge. All right, so temp dot merge mean price on cat. So the cat, what was the cat? Cat was exterior second. Do remember the cat inside this method we will be iterating one by one category. First we will go for neighborhood, exterior, and then exterior second. Since we have created this mean price and this temp data for the exterior second, so we are gonna just put here, let me see here, we are gonna just put here this exterior second. All right, thereafter once you run this, you will see there you have exterior second, percentage of houses, and the sale price. All right, now it has become one complete pandas data frame, and then finally we will be plotting it. So this data frame is being returned by this method, this Python method. Let's go ahead and run this. Now once you run this, thereafter what I'm going to do, I'm going to just I'm going to get something like this so that you can understand what's happening here. All right, so get mean sales price per categories. There in the data frame I'm passing here a data, and this exterior second. The thing what I want to show you here is that earlier I had shown you this one for exterior second out of the for loop, how you can do these things manually, and we had got this data frame. Now the same thing I'm gonna show you with the help of this method, and if you run this, sorry, this should be actually, there should be a return. If you run this, you will get the exactly the same data frame which we had seen here. All right, so that's the data frame which we are having. Now we are going to do a plot. All right, so do you see there we already have a plot for a categorical and the percentage of house, but we do not have a plot for a mean sale price. So this one is mean sale price for each of these categories, each of these unique labels for exterior second category. All right, so let's go ahead and write here plot category. All right, so we are gonna do here plot categories, data frame, and category. Do remember now what's gonna happen here, this data frame which is already actually let's say we are gonna take it in extdf. We already have this one. Now we can simply do like the plot, but this is not gonna work. Why it is not gonna work? We can get here the sale price properly. But what we want a line plot for this column, but a bar plot for this column. That means we cannot simply use this one. We have to use something else here. So the thing which we are going to use line plot for a sale price and a bar plot for a percentage of house. And for that case, we have to create a two axis. The one axis is going to be primary axis, and there is going to be a secondary axis. So in the primary axis, like we had seen previously, like this one, I'll be using a percentage of houses, and for the secondary axis, I'll be using a mean house price. All right. So in that case, what we need here, we need a twin axis. So I'll show you how you can create a twin axis. Let's go ahead and first create this one, figure, and axis 1, we are gonna get it from plt.subplots. All right. And thereafter, we are gonna set here the x ticks. So x ticks, we are gonna set here df.index. So the data frame dot index. All right, so the data frame dot index, so those are going to be the tick, and thereafter on the x tick, that's mean the number of position on which we are going to set here, that's the data frame category. All right, so for a particular category, let's say if we pass here a particular category, so these are unique labels, so those are going to be set here at these ticks. All right, that's the df cat. Thereafter, I'm going to also set here the rotation. All right, so there I'm going to set here this 90-degree rotation for the labels which will be set on x-axis. Thereafter, we have here ax2 is equal to ax1 dot twin x. All right, so there we have a twin x-axis. So in this way, what's going to happen, there would be one primary axis, there would be another secondary axis. Now in the primary axis, I'm going to set here a bar plot, and in the bar plot, it takes x labels and y label. In x label, I'm going to set here df.index. All right, thereafter, I'm gonna set here the y data as a df percentage of houses. All right, it was this one. All right, so there we have got data frame percentage of houses, and thereafter the color which I'm gonna set here, I'm gonna set here a light gray color. All right, thereafter, this is for axis 1 plot. Let's go ahead and do for axis 2 plot. That's the secondary axis, ax2.plot df.index, thereafter df.sale price. All right, thereafter it's going to be like this. Color is equal to green, and then label we are gonna set here the label is house price actually. All right, perfect. Now let's go ahead and set the 5% bar on axis 1, that's the ax1 dot axis h line. All right, y is equal to 0.05, and the color I'm gonna set here the red color. So there we have axis 1 is equal to set underscore y label. All right, so in this y label, what's gonna happen, axis 1, for axis 1, I'm saying that this is the percentage of houses per category. All right. Thereafter, we are also gonna set here axis 1 X label, and in the X label we are gonna set here the category, and thereafter we are also gonna set here axis 2 Y label. All right, to Y label. So that's the mean house price per category. All right. Thereafter, we are gonna simply do here the plt.show. All right. It says that we have an error. Let me see, where is that error? Perhaps here. All right, perfect. So we have got the two things. First, we have seen get mean sales price per category. We have got like the mean price like this one. And now we have customized our plot so that it can plot for a first column, a bar plot, and a line plot for a second column. So similarly, I'm gonna do here the plot underscore cats. In that, I'm gonna plot here the temp. All right, there if you remember something like this, and exterior second. All right, let me see it here. Sorry, I think I have not done a merge perhaps in the temp. Let me see, where is temp? Yeah, there. All right, so what I'm going to do here, I'm going to simply write the t is equal to like this. All right, and there is t. So this t I'm going to simply pass here like this. Now once you pass that one, you will see this beautiful plot for exterior second. So what it says that in exterior second, it says that these are the bar plot for these unique labels and these are house prices. And this is not representing anything the fruitful. What's happening here? These some rare occurring label house prices are pretty much high. All right, and the sum for some other label house price is less. I mean to say that in this, what do you notice is that for these, some of these rarely occurring labels, price is quite high than these regular occurring labels. So these label, do you see there? These are not much difference, but the price is fluctuating too much if we have these some of the rare occurring labels. So that's why rare occurring labels could be an important factor in your machine learning algorithms. Now this is just for one column. Let's go ahead and do this for all the columns. So for call in feature columns, thereafter we have here a temp is equal to get mean sales price per category. There we have data and we are passing here a column. Thereafter we have here a plot categories, and in that we are passing here the temp and the column. Let's go ahead and run this. It will plot for all the three columns. In out of those three columns, what do you see? The one thing we see here is this one. This is quite irregular for the first one. That's been for a neighborhood. But it could be useful in exterior first and exterior second. All right. So this could be useful in these two cases. So this is how you can do the analysis of rarely occurring labels. Now the question again comes that what do you get that? What did you get with this analysis? You might ask that, okay, I knew that this could be a problem. All right, so what was the new there? The new is that now you have understood with this proper plot and the graph how it is happening. Now the another method I'm gonna say that I'm gonna show you that how you can do the grouping of rare occurring labels. All right. So there, all right, I'm gonna just say that grouping of rare labels. So what's happening here in these rare labels? We are gonna just regroup all those labels which are occurring less than 5%. All right. So for less than 5% labels, we are gonna group them together. So I'm gonna create here def rare labels grouping. In that we have data frame and the category for the particular category which we want to regroup together. Now do you remember we had there a temp is equal to data frame. There was a category and then we had here value counts divided by total houses. That's the percentage. Now what we need to see here, we are going to let me see, if you remember this was the T. So these are the some labels which are happening less than 5% like this. So we are going to group these together. That means to say that we need to first find out that which are those labels which we need to regroup together. And for that I'm gonna create dictionary. That's the grouping dictionary. All right. So in this grouping dictionary, what's gonna happen there? There is K, and this K is actually you see it in some other way. How would you see this? It's like the mapping. So the mapping is like I'm gonna create dictionary, something like this. Let me show you the first here, otherwise you might not understand that what's happening here. So what I want to do here, I want to keep labels as it is for these because the percentage of labels are more than 5%, but for these I'm gonna put a new label, something like this. So I'm gonna create dictionary like this where I'm gonna say rare. All right, and similarly like this one, something like this one. So what will happen once we run mapping of this dictionary on this data, you will see that these two columns will be replaced with the rare. So it's like this one, t dot map. Sorry, let me run this one. Thereafter you will be having this one. All right, so like this one, t dot map. Sorry, I think we can use that on this column only. All right, like this one. So what do you see there? There is mapping. A mapping has happened for 5th and the 6th. So similarly we need to also set for others. So which are having more than 5%, we need to map those as same. That means exactly in the same way. This will be mapped to this variable. This will be mapped to this variable. But these will be mapped to a rare variable. All right. So that's the thing I'm gonna do here. So the first of all, I need to write here for k in temp dot index. Now what is this temp.index? Do you see there? Temp.index is, sorry, this should be actually the t.index. No, okay, so it's actually like this one. So if you do like this, sorry, oops, something else came, just let's say exterior second. Yeah, so these are the index, that's mean these are the unique variables. So I'm just going to iterate over one by one. That's the for k in temp index. Now this is kind of a comprehensive dictionary. So now I'm going to say here k will be mapped to the same values if it is greater than 5%. In that way, I need to run here some else. So I'm going to say here if k not in temp, all right. So there I'm going to say here again temp is greater than or equal to 0.05 dot index. That's mean it is going to get all those labels which have greater than or equal to 5% indexes, and it will be, if it is not in this one, then it will be mapped as rare. All right, so this could be a little complex for first time. And now this is if else, and if it is inside this one, then in that case we want exactly the same as k. So the moreover, what's happening here, this for is working from here and these things are working from here. Once it is done, then I'm gonna say here there is a t is equal to df cat dot map its grouping dictionary, thereafter return t. So there is error, it says that perhaps this could be. All right, so we have rare labels grouping. Once you get this rare labels grouping, and let's see for exterior second what's happened there. We have rare labels grouping, in that I'm passing their data and I want grouping for exterior second. So you get something like this one. All right, so the grouping has been done there. There you can see rare labels are also coming, and if you do their value counts, then you will see there other labels have been removed which were occurring less number of times, and there is new rare label has been introduced which have high number of high number of occurrence. Now these seems to be in a same scale, and these are not seems to be like this one. All right, so what we are going to do here, we are going to create a new column in the data. So there is the data, and in this data it is going to be for exterior second. All right, so that's for this one. And in this way, what's happening there, data exterior second, do you see there we have got this exterior sorry, there is just a mistake there. This should have been actually, all right, so if it is there, let it be, no issues, because we don't need a second time. Otherwise I think we need to do, otherwise there would be a problem. All right, That's for this one. And similarly, I'm going to do for exterior first one. All right. And similarly, I'm going to do it for neighborhood. All right, so I have got this overall data. All right, so in this data, there is rare and other things are coming. Now let's go ahead and once again plot it in the same way which we had done earlier, like this one. All right. Now we have introduced here a new grouping of the data. Now everything will be same here. We don't need to change anything. That's beautiful. Do you see there the differences? Earlier we had so many variables which were occurring less than 5%, but now we don't have any variables which are occurring less than 5%. So what do we see there? There is rare, and these rares collectively is happening so. That's been okay in the neighborhood. But if we see here in the exterior 1 and the exterior 2, in that case, these rare are really very important, because for these rare materials, house price are really quite high. These rare materials mean house price is really quite high, except the first one. Otherwise, it is the highest one. So, the claim which I said at the start of this video lesson, that rarely occurring words, rarely occurring labels could be important in some case and it could not be important in some case. Because for this column, for a neighborhood, this is not much importance. But it is having a lot of importance if we take exterior first and the second type of the material. All right. So that's the beauty of this rare occurring labels analysis. So this is all about in this lesson. Thanks a lot for watching it. It has been almost more than an hour to take this lesson, and thanks a lot. And please do not forget to like this video and subscribe this channel, and you will get a direct notification whenever I publish new videos on my channel. Thanks a lot for watching it. Bye bye. Have a nice day.